Section 3.1 Quadratic Functions and Models. Polynomial function. A polynomial function f of degree n, where n is a non-negative integer, given by, this is the function x, this is called polynomial functions, and an minus 1, a1 to a0, this is all real numbers. And then the n, this is the variable with the degree n here. Okay, you could see the polynomial function. We always write it as a descending orders. Okay, n minus 1, n minus 2 until 1, 0. Okay, and then the highest degree, we call this is gonna be the leading term. The coefficient of the leading term will be the an here. Okay, look at the example for polynomial functions. This one, f of x equal to 2, we only have the constant here. We don't have any variable. So we say the degree is going to be equal to 0. And the leading coefficient, an, that will be equal to 2. Okay, one more time. The leading coefficients, talking about the highest degree of the constant number here. Second one, we do have two terms. This is a linear equation, right? Y equal to 5x minus 1. So we do have the x, this is on the first degree. So degree n equal to 1. And then the leading coefficient, that will be the 5 here. This one, we call this as quadratic equations. The highest degree will be equal to 2. Okay, n equal to 2 here. And the leading coefficient will be equal to 4. This is the cubic equation. So the degree is going to be equal to 3. N equal to 3 here. This is the highest degree. So the leading coefficient, that will be equal to 2 here. Make sure you remember that polynomial functions, we always write the degree from the descending orders. Now, these sessions, we want to focus on the quadratic functions. Quadratic functions, that will be y equal to ax squared plus bx plus c. Okay, and usually we replace the y with the function of x. A, b, and c are the real numbers, and a cannot be equal to 0. Okay, quadratic functions. So this is going to be the second degree. Okay, n equal to 2. We need to know how to graph of f of x equal to ax squared. So all quadratic functions have graphs similar to y equal to x squared. Okay, y equal to x squared. And keep in mind that this is called parabola. Okay, parabola. They are the U-shaped and symmetric. With respect to a vertical line, no one has the axis of symmetry. Okay, let's look at this example. Let's try to use the table to graph this equation. Okay, f of x equal to x squared. So plug in the point first. Plug in x equal to 0. So you're gonna get y equal to 0 here. Okay, try to do it by yourself. Plug in all the points in here. Okay, this is what you guys get. Based on the graph, we try to sketch y equal to x squared. Okay, we have a 0, 0 here, 1, 1, negative 1 and 1, 2, 4, and negative 2 and 4. So this is called parabolas, and it's going to be going upward. Okay, that's a U shape here. Okay, this curve is y equal to x squared. And then, I need you guys to highlight this one. We do have the vertical line. This is the vertical line. You just bisect the parabolas and make it like symmetric. And we call this is the axis of symmetry. Okay, that's a vertical equation to cut it half of the graph here. Okay, and we call this as the axis of symmetry. And this equation, we call x equal to 0. One more thing, we do have the vertex. In this equation, the vertex is going to be the minimum point. And this point will be 0, 0. Okay, if I give you guys an equation, I need you guys know how to graph it. Find out the axis of symmetry. Okay, one more time. Axis of symmetry, this is an equation. And also, I need you guys find out the vertex. Okay, what is the minimum point or maximum point? Okay, think about it. What is the domain? Domain will be all possible values of x in here. So that will be from negative infinity to positive infinity. And then the range, since the vertex here, this is the minimum point. So we're gonna starting from here. Bracket 0 until positive infinity. Okay, this one. I want you guys try plug in the points and try to sketch f of x equal to 2x squared. Okay, check your work. Sketch the graph. So first, think about it. What's the equation of axis of symmetry? This line is gonna be bisect the parabola, right? So how to call this equation? This is x equal to 0. Okay? What is your vertex? 0, 0. And then the domain, same thing, right? All possible values of x. And then the range, that will be from 0 to positive infinity. Okay, I want you guys compare this one, f of x equal to 2x squared. Okay, and then the previous example, we graph f of x equal to x squared. What is the difference between these two? When you have a f of x equal to x squared, the graph is gonna be looks like this. When you have a constant number, when you have the a here, and this number is gonna be greater than 1, then the graph is going to be narrower. Okay, f of x squared is going to look like this. And then when you have a 2x squared, then this curve is going to be close to the y-axis. It's going to be more narrower. Okay? Okay, this one. Try plug in the points and try to sketch this function x. Try to sketch this f of x. Okay, check your work. And this time, since we do have a negative number, okay, negative, the a is going to be negative 3. So the graph is going to be going downward, okay, going downward. So what is the axis of symmetry? The same thing, right? X equal to 0. What is the vertex? The vertex in this example, we call this is going to be the maximum point. Okay, the maximum point. That will be from 0, 0. Okay, what's the domain? Same thing from negative infinity to positive infinity. And then the range. Watch out the range. We're going to look at starting from negative infinity until 0. This is the maximum point, okay? So negative infinity to 0 and bracket, because can be equal to 0. Okay, so we summarize. We do have this example. The first one here, f of x equal to x squared. Okay? When you have the a, the constant greater than 1, just like the 4, then the graph is going to be much more narrower, okay? But if your A is in between 0 and 1, just like 1 over x, this is in between 0 and 1, then your graph is going to be wider, okay, wider. When you have a negative number, then the graph is going to be going downward, okay? We call this as all upward because it's a positive values. Okay, get the idea. So, when we have this graph, this is the parabola. Axis of symmetry will be x equal to 0, vertex that will be 0 and 0. And when a greater than 0, then it's going to be open upward. Alright? When a less than 0, that will be going downward. And then, when a is greater than 1, then the parabola is going to be narrower. But when a is between 0 and 1, then that will be wider, okay? Okay, now we're going to look at the f of x, this one. This time we do have a times x minus h squared. Okay, this is the same idea with this graph. The quadratic equation, f of x equal to ax squared plus bx plus c. B and C is not equal to 0. And then, remember we learned the computing the square method. Okay, we applied the computing square method. We could rewrite the equation into a times x minus h and square. And h, this is going to be the constant. For this function x, they will have the same shape of the graph y equal to ax squared. And then when you see x minus h, when h is positive, you're going to shift the whole graph h units to the right. Okay, when h is a positive. For example, when I have x minus 2, you're going to shift the whole graph to the right 2 units. But when your h is a negative number, for example, h is going to be negative 3. So I'm going to get x plus 3 squared. Then you're going to shift the graph 3 units to the left. Okay, you're going to shift to the left. Since we shift the graph already, since we shift the graph to the left or to the right, the vertex and axis of symmetry will be changed also. So the vertex will become h and 0. Whatever you have h here, that will be h and 0 here. And then the axis of symmetry, the previous example, we find it as x equal to 0, but this time it's going to be x equal to h. Whatever you have on the vertex here, that will be your axis of symmetry. Okay, let's try to work on this example. We know how to graph f of x equal to x squared, right? But this time we do have x minus 2 and then square. And remember that when h is a positive, we're gonna shift h units to the right. Okay, so meaning that for the f of x equal to x squared, we do have like that way, right? The U shape. And then you're gonna shift 2 units to the right. Okay, let's try. You could plug in the points. Okay, and then suppose the graph, the vertex is gonna be here, right? And then we're gonna shift 2 units to the right. So now, what is the axis of symmetry? Think about it. What is this equation? This is called x equal to 2, right? So this is gonna be my axis of symmetry. And then what is my vertex? Minimum point is here. That will be 2 and 0. Okay, domain, same thing, from negative infinity to positive infinity. The range, look at the y here. It gonna be starting from 0 until positive infinity. Okay, one more. And this time we're gonna add the k here. Okay, we just cover this part in the previous example. Right now, we're gonna add the plus k. This has the same shape of the graph of y equal to a, x minus h squared. And then when you add k here, when k is a positive number, you're gonna shift k units upward. So you're gonna shift upward k units. When k is a negative, you're gonna shift downward. Okay? And then the vertex become h and k. Okay, watch out the sign here. This is the standard form of this equation will be x minus h squared plus k. Okay, then h, this is a h, k, and this is k. Okay, that will be your vertex. And the axis of symmetry will become x equal to h. And when a is greater than 0, then the graph is going to be upward, right? When we have an upward, we do have the minimum function value. But when a is a negative number, then the graph is going to be downward. When we have a downward, we do have the maximum function value for the k. Okay, this is more details for the summary. One more time. A is greater than 0, going to be upward. A less than 0, that will be downward. And then when A greater than 1, the graph is going to be narrower. When A is going to be between 0 and 1, then the graph is going to be wider. And then within the parenthesis, the x here, within the parenthesis, the h here, when it's a positive, you're going to shift to the right. When h is a negative, you're going to shift it to the left. And then the k here, this is called vertical shift. When k is a positive, you're going to shift upward. K is negative, you're going to shift downward. Okay, right? Let's try this one. Okay, look at this example. First, think about it. Is this graph is going to be open upward or downward? That will be open upward, right? Because this is going to be positive number. And then the A is going to be greater than 1. Okay, so it should be wider or narrower? It should be narrower, right? Because greater than 1. And then x minus 1, the h is a positive value. So you're going to shift to the right 1 unit. And then the k is positive. So you're going to shift upward 4 units. Okay, you could sketch the graph or you could use the table. So you're gonna see the graph like this. Okay, one more time. Shift right 1 unit, shift upward 4 unit. 1, 2, 3, 4. Okay, and then a little bit narrower because of the positive 2. Now, answer the questions. What is the equation of axis of symmetry? This line, this is called x equal to 1. What is the vertex? The minimum point here. That is 1 and 4. Okay, what is the domain? Negative infinity to positive infinity. And in the range, the minimum point will be 4 here. So brackets 4 until positive infinity, parenthesis. Okay, next one, example 5. So we do have the quadratic equations here. Okay, so when you see the quadratic equation, you want to rewrite it as this form. A times x minus h squared plus k. That will be easy to finding the vertex h and k, and also easy to find out the axis of symmetry. Okay? Okay, let's do it together. We need to apply the computing square method. First, we need to double check. The coefficient of x squared here is a positive 1. We need to have a positive 1 in order to do the computing square. So this is good, right? Positive 1 x squared. So we're going to group these two guys together. And then this is going to be my b, right? We're going to adding b over 2 square. Okay, b over 2 squared, which is gonna be 1. When you add 1, we need to subtract 1 also. Okay. Then you're gonna look at this guy. Factor this one using your x method. It has to be the perfect square for this guy. If not, then you make a mistake. That will be x minus 1 squared. And this is negative 1, which is going to be negative 2. So this is the one we are looking for, right? A times x minus h squared plus k. So you're going to know, you're going to shift your graph to the right 1 unit. And then negative 2. So you're going to going down 2 units. Okay, what is the axis of symmetry? That will be x equal to 1. What is the vertex? 1 and negative 2, right? Okay, the domain, negative infinity to positive infinity. And then the range, this is going to be the minimum point. So it's going to be bracket negative 2 to positive infinity. Okay, this one. Same thing, we want to write it as a standard form, right? Okay, let's try to do this example together. And this one, we need to apply computing square method, but our coefficient for x squared, that's a negative 2. Okay, so we need to make it like positive 1. Okay, first, what are you gonna do? F of x equal to negative 2x squared plus 6x minus 3. So first, I will divide it by negative 2 for the whole equation. So negative 2, I only have with x squared and minus 3x plus 3 over 2. Let me leave some space here. Plus 3 over 2. Okay, right? And then we're gonna add b over 2 squared. Okay, so the b is gonna be negative 3. So I'm gonna do 3 over 2 squared. When you add something, you need to subtract something. Okay, so when I cancel out, that will be exactly the same question as the original one. Okay, now I want you guys only look at these terms here. Okay, so remember the computing square method, that will be x minus 3 over 2 squared. And then we're gonna take care of this guy. So minus 9 over 4 plus 3 over 2. Okay, we're gonna take care of the constant here. We're gonna times 2 to get the LCD. Okay, so x minus 3 over 2 squared. This is gonna be negative 9 plus 6. So negative 3. And that will be 4 here. Okay, we still the negative 2 here. Make sure at the end you want to multiply the negative 2 for both sides. So this guy, keeping the fx. And then I have a negative 2x minus 3 over 2 squared. Negative become positive. Cancel out. So plus 3 over 2. Okay? So this is how I do the computing square method. You could look at the solution a little bit different from mine, but we're going to get the same answer. They didn't divide it by the negative 2. Instead, they factor out the negative 2 for the first 2 terms here. And then they're going to add 3 over 2 squared, which is going to be 9 over 4. Okay. And then this guy, they take it out. Negative 2 times negative 9 over 4 become positive 2 times 9 over 4. They keep this guy here, okay, just like mine. They want to factor out. So they have this one. Okay, they simplify it. You're gonna see I do have the same answer as the solution. Okay, the only difference is I try to divide it by the -2 for the whole equation. And then once I'm done for the computing square method, I multiply by -2. Okay, but they gonna factor out the -2 instead. Okay, both of the methods are correct. It doesn't matter. You use this method or you use this method. Okay, they're gonna get the same answer. Okay, after that, since this is a negative, so it's going to be going downward. Okay, and this is going to be shift to the right 3/2 unit, which is going to be 1/2, right? And then go up 3/2 unit. Okay, what is the axis of symmetry? That will be x equal to 3/2. The maximum point or the vertex, that will be 3/2 and 3/2. Domain from -infinity to +infinity. And then the range starting from -infinity until 3/2 brackets. Okay? Okay, and then the vertex of a parabola. The vertex of parabola given by, we do have these quadratic equations. And then without using the computing square method, we could apply the vertex formula. We could just find out the vertex directly. This is the formula. When you find the coordinate of x, you could use -b/2a. Okay, -b/2a. After you get the x coordinate, you could put it back here to find out what is your y coordinate. Okay, I'm not going to ask you guys memorize this guy. So the x coordinate of the vertex will be -b/2a. And then the axis of symmetry is going to be exactly the same thing. Let's try to do this example. Find the axis of symmetry and the vertex of the parabola using the vertex formula. So first, let's determine what is your A, B, and C. A will be equal to -3, B equal to 12, and C equal to -8. And then the x coordinate will be equal to -b/2a. So plug it in. Simplify it, you should get x equal to 2. Once you're done, you want to find out the coordinate of y. So you plug in x equal to 2 into this equation. Simplify it, you're gonna get the 4. And what is the axis of symmetry? X equal to 2. Okay, x equal to 2 will be the axis of symmetry. And then vertex will be 2 and 4. Finding intercepts. For any function f, the y-intercept occurs at f of 0. Plus, for the function x, ax squared plus bx plus c, the y-intercept is simply 0 and c. When you want to find the y-intercept, you want to plug in x equal to 0. When x equal to 0, you're going to plug in here. You're going to see f of 0, that will be equal to the c. That will be your y-intercept. If you want to find the x-intercept, and this time you're going to plug in y equal to 0 and then solve for your x. So for this equation, when you plug in y equal to 0 means f of x equal to 0. So you want to solve your x-intercept by factoring this guy. After you find the y-intercept and x-intercept, you could write it down the points in here, and then graph it depends on the a. For this example, a will be negative number. When a is a negative number, then the graph is going to be looking downward, pass through the y-intercept and x-intercept. Let's try on this example. So we do have the parabola here, and then my a, that is equal to -3. So we're gonna know we do have a downward. The graph is gonna be look downward. And we need to identify the intercept of the graph. So first, let us find the y-intercept. When you want to find the y-intercept, you're gonna plug in x equal to 0. Okay, x equal to 0, these two guys become 0. So it's only equal to 1. So the y-intercept, that will be equal to 1 here. Now, we want to find out the x-intercept. So we want to plug in y equal to 0. Means f of x equal to 0, this whole equation equal to 0. So let's try to rewrite it to the standard form. Now, use the x method. We factor out, you're gonna get 3x minus 1 times x plus 1. Solve for your x. So x gonna be equal to 1/3 or x equal to -1. And then one more time, this is your x-intercept, okay, when y equal to 0. That's it.